A distant and mysterious planet of the dwarves, Pluto was once considered a full member of the planetary family of our solar system. The recent surprising announcements of deGrasse Tyson and Michio Kaku's leading astrophysicists have created Pluto on the spot with a shocking discovery. They suggest that a glossy world is in the process of a possible conflict with Neptune. But how does this happen, and what will be the outcome of such a large event? Are there any unusual astronomical phenomena, or more in the upcoming space conflict? Join us as we explore the possibility of a Pluto-Neptune collision. Pluto, a former planet, has been relegated to dwarf planet status due in part to its unusual orbit, but it still remains a subject of fascination and study in astronomy. Recent predictions of leading scientists put Pluto's orbit dangerously close to the forecast of Neptune. Neil deGrasse Tyson and Michio Kaku both raised the red flag about the possibility of a dangerous clash between two planets, which can even threaten the Earth. But how can such an event be possible? Pluto's trip around the Sun is like no other planet in our solar system. It takes 248 years to complete one revolution, which means that it has not yet completed a complete revolution since its opening in 1930. Adding to his interests is a very elliptical orbit of Pluto, which significantly deviates from the almost circular orbits of the main planets. Pluto's orbit also looks at 17 degrees compared to the ecliptic, which makes it much fresher than other planets. This inclination and elliptical nature add difficulties to the orbital models. One of the most interesting aspects of Pluto's orbit is its intersection with Neptune. During each orbit, Pluto actually gets closer to the Sun than Neptune. This is far from what we expect from our location in the solar system. This leads to a natural question. Why did Pluto encounter Neptune? The answer lies in the effects of gravity on another planet. The study of Pluto/S orbit began almost immediately after its discovery. Initially, astronomers tried to understand its unique trajectory. Unlike other planets, its orbit is relatively close to the ecliptic, and Pluto's orbit is notable for its sudden trends and elliptical shape. The secrets got deeper when it was discovered that Pluto's orbit actually passed through Neptune's orbit. Despite this complexity, the stability of Pluto's orbitals demonstrates the complexity of the dynamics of the universe. A three-body universe problem that understands how Pluto, Neptune, and the Sun, the three bodies interacting with each other, can help explain it. Azimuth is a sticky, extent vibration, and VZLK oscillations are part of this puzzle. Azimuth of oscillations means that each time Pluto crosses the orbit of Neptune, it is located at least 90 degrees of Neptune, providing a spatial separation which prevents the shock. Latitudinal wobble refers to the vertical movement of a celestial body in its orbit. In Pluto's case, this means that it is well above the orbital plane when approaching Neptune or another giant planet, adding another layer of protection. Named after scientists who study how gravity interacts in space, the VZLK wobble better explains Pluto's unusual path. Although Pluto's orbit appears unstable, the wobble helps Pluto move smoothly over long periods of time. This shows that even though objects in the universe appear rough and random, some patterns and rules maintain order. These components combine to keep Pluto's orbit stable and prevent it from colliding with Neptune. Numerical simulations from the late 1980s showed that despite these stabilizing properties, Pluto's orbit is technically chaotic. Small deviations from initial conditions can lead to significant differences over millions of years. However, Pluto's unique orbital features have been found to be stable for incredibly long periods of time, effectively preventing chaos. Recent computer models have shown how the major planets Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. There is a special connection between Pluto and Neptune. For every 2 orbits Pluto makes around the Sun, Neptune makes 3. This synchronization helps keep Pluto's orbit stable. Jupiter's gravity also plays a role in keeping Pluto stable, and Saturn has a small but beneficial influence. These planets work together to ensure that Pluto continues its journey safely through space. These gravitational interactions are necessary to maintain order in the solar system. Without them, the solar system would be much more chaotic, and bodies like Pluto could potentially collide with other bodies or be kicked out of their stable orbits. Understanding Pluto's orbit is particularly important given recent concerns about a possible collision with Neptune. It gives us a clearer picture of the dynamic nature of the solar system and shows how seemingly unstable orbits can reach equilibrium through complex gravitational forces. Studying Pluto-S orbit provides insight into the unpredictable nature of celestial bodies. The concept of orbital chaos, where small changes in a celestial body-S position can have large effects on its long-term path, is clearly illustrated in the case of Pluto. IT modeling has played a key role in studying this dynamic, allowing scientists to check whether small changes under initial conditions can mainly change the orbit of Pluto over millions of years. Despite this chaos, Pluto's orbit remains stable for billions of years, showing that even unstable means can demonstrate long-term forms. The forecasting of space events, especially those in which chaotic orbit participate, such as Pluto-, is a serious problem. Modeling depends on the accuracy of the initial conditions, and even small errors can lead to completely different results, which complicates the exact forecasts. This unpredictability reminds us that despite the great advances we have achieved in understanding the universe, our knowledge is still limited. The effects of the gravity of giant planets on Pluto provide valuable information on the wider dynamics of the solar system, indicating how each planet's position affects the stability of others. So why are the main astrophysicists now concerned about the possibility of a Pluto-Neptune confrontation? Neil deGrasse Tyson, an exceptional astrophysicist, known for his contribution to Pluto's advertising, offers a unique perspective. He believes that advertising is viewed not as a decline, but as an adaptation to an expanded understanding of the solar system. Tyson believes that studying the complexity of orbitals such as Pluto can teach us more about the universe, and that a hobby to the unknown will inspire the field of astronomy. Theoretical physicist Michio Kaku emphasizes the need to study the broader implications of our knowledge of Pluto's orbit. He advocates investing in space research to prepare for future risks that could arise from celestial interactions. He also highlights the role of advanced technologies in understanding and mitigating risks associated with space events. The potential collision between Pluto and Neptune is not merely an astronomical curiosity, but also reminds us of the dynamic and unpredictable nature of the universe. This makes us think about the vulnerability of heavenly dynamics and the potential consequences of disturbances in the orbit of the distant world. As scientists continue to improve their models and simulations, they open up new opportunities to understand the ever-evolving nature of the universe. The study of Pluto's orbit serves as a stepping stone for a broader discussion of the need for constant vigilance in the study of observations of the universe and heaven. By looking to the future, new technologies will undoubtedly expand our research capabilities. Missions like NASA New Horizon, stolen by Pluton in 2015, already provide unprecedented data on the dwarf planet, its moon, and its geological features. The results of the mission revealed the complex landscapes of frozen mountains, large plains, and even cryovolca, poses questioning long-sighted hypotheses and expanding our understanding of geological activities in the external solar system. In conclusion, the discussion of the possibility of a Pluto-Neptune collision highlights the complex dance of celestial bodies in our solar system. The interaction of chaos and stability in Pluto's orbit is evidence of the complex structure of the space neighbors, in which each body plays a role in maintaining balance. Whether a collision will occur remains an open question, but it serves as a reminder of the vast and ever-changing nature of the universe we live in. As we continue to explore the universe, its mysteries call us to discover the wonders that lie beyond our own planet, and the stories of Pluto, Neptune, and other celestial bodies guide our quest for understanding. The dance of the planet continues, stimulating excitement, and is amazed at how it shapes the journey of humanity deep within the universe.